All right. So welcome everyone to the first office hours of week 3. In this office hours, we're going to be going over the week 3, day 1 content, which is the introduction to composability. There was an awesome video by Nick that went over smart contract composability as an introduction. And the rest of the README was going over the technical implementation, or how we at the Decentology team have been approaching implementing composability on Flow. And at the end of this office hours, we will also go over some of week 3, day 2 content, because that was just a simple extension of the content that was in day 1. So, as you probably realized, there were no videos for day 2, but there was just a README that was going over some of the problems with composability that we'll learn about in this office hours and how to tackle them. So what I want to do is just go over the technical implementation of composability on Flow with you all in this office hours. I'm going to be using the GitHub repo that I posted in the day 1 README. And that can be found if you actually go to the quests all the way at the bottom. That can be found in this link right here. So we're just going to be working with this repo. Now, what I put in this repo is just a simple example of composability. Now, it probably won't be simple at first because there's a lot of confusing elements to this. And as you can see here, I'm about to throw a lot at you, so get prepared. There's definitely a lot to read, a lot to learn. So hopefully this office hours will help you further understand how we're approaching composability. So let's just skip to this part where I start describing what each of the contracts does. So assuming you've read this first part, what we're really doing is trying to set up a system where we call a tenant the person that is going to be interacting with our registry. So the registry is a term we're using to describe where all of the registry contracts are going to lie, or the composable contracts / modules. And these composable contracts are going to be used by a caller contract, or a calling contract, or we also refer to it as a DApp contract. The person that's implementing that DApp contract will use these composable modules to help them in their implementation. And if you've looked at the GitHub repo, you'll see that, if we go to our project folder, and I'll go over this again in a second when we come back to it, but in this example that we've set up, we have a marketplace contract that, is in our project folder. So in this fake scenario, we're assuming that we wrote this marketplace contract, and we're using a registry NFT contract that already exists in the registry to, get our marketplace going very quickly. And so let's actually close this for now and come back to this when we go over, what registry service means, what registry NFT contract means, and all that. So to start off, we have the registry service. And this is mainly used to, it's mainly used initially when you as a tenant are coming into the, composability ecosystem, where if you want to use any contracts that exist in the registry, or if you want to use any registry contracts, you first have to call into this registry service and register yourself with the registry. So this happens as described here, and let's walk through this together. So the registry service is a contract. Inside of it, there are 2 things you have to know. There's an auth NFT resource. This is a resource that anyone who wants to use registry contracts must have. I'll explain why in the registry interface section, so we'll go to that in a second. And note that someone who wants to interact with the registry, aka a tenant, only has to get an auth NFT once. So this means that if I, have my, DApp contract, and I, want to use a registry contract, I need to have an auth NFT, right? But if I make a whole new project that's completely different, if I have another DApp contract, I can still use my same auth NFT for any registry contracts that are out there. So this only has to happen once per tenant. And then the second thing that registry service has is a register function, and this returns a new auth NFT to the tenant. That's it. So let's actually walk through what this means in the code. Now, the way that I've set this up is, this flow directory has non-fungible token.cdc. This is not really useful for this example. It's just included here, as you probably saw in the kitty items repo that we were working with last week. This just has the non-fungible token contract interface, but we're going to completely ignore this for now. The two that we're going to focus on are project and registry. So the registry has registry service in it. So let's actually start here. And the registry service is not something that you will implement. This is something that the Decentology team has implemented, and you're simply just going to be using the auth NFT defined in here to interact with the registry, as a whole. So registry service has an auth NFT, and this auth NFT you can see has, well, actually I deleted this in the production example, so you won't see that. But essentially the auth NFT has one main thing, and this is an auth ID. And what this auth ID is just a unique ID for every tenant that comes to the ecosystem, and it's just incremented by total supply. And this is just used as, if you've seen NFTs, each NFT has a unique ID. We followed a similar concept with auth NFT. Now, in the future, there's going to be a lot of other fields here. We don't know what that is yet. We're still exploring this, but this is just for our purposes. We're going to give each auth NFT a unique ID so that we can identify each different client or each different tenant. So what this auth NFT is, that's described in the README, is whenever a tenant comes to the registry ecosystem, they need to have this in their account. So what's going to happen is if we go to our transactions, and we go to the registry folder, you'll see there's a transaction called the register with the registry. So in this transaction, you'll see that there's really one thing that's going on. Well, two things. First, it's checking to see if this account already has an auth NFT. And if it doesn't, if it's nil, right, then it's going to account.save. So we're saving this to the account storage, a registry service, and then we're calling .register. Now, all register is doing is just returning a new auth NFT, right? So what's happening is each tenant is just storing an auth NFT in their account storage. And like I said before, once this happens, it never needs to happen again for that tenant, right? They can use this auth NFT for any registry contracts that are out there. So the registry service is simple enough. And in the future, this will also be, much more complex. We're thinking about, including some sort of payment systems and stuff like that, but that is beyond the scope of what we're learning in this bootcamp. For now, just know that the registry service has an auth NFT that each tenant must have to, almost use as a key to get into the registry. So let's move on to the registry interface. So I'll walk through this pretty much word for word and then explain what I mean. So the registry interface is a contract interface. So this is much like the non-fungible token contract interface that we went over during last Monday, during week 2, day 1. It must be implemented by registry contracts if they want to be in the registry. So we will learn what this means in a second. Thus, the interface defines a few things that every registry contract must have. So every registry contract must have a client tenants directory. This keeps track of how many tenant resources each tenant has. It maps the address of a tenant to the number of tenant resources they have received. So let's go through this one. If we go to our registry interface, again, this is a contract interface, and I've written some comments here that go over this. You'll see that it actually imports the registry service, and we'll get to that when we get to the instance function. So the first thing that I went over was client tenants. Now, you'll see this is a dictionary that is only accessible by this contract, and it maps an address to a uint64. So what this does is it maps the address of a tenant to the number of tenant resources that they might have. So, if you think about a registry contract implementing this interface, when you get a tenant from that contract, it will increment this number, right? So if my address is 001, then when I get a tenant from a registry contract, it will say 001 maps to 1. And then if for some reason I got another tenant, it would map my address to 2. So this is really just keeping track of which addresses or tenants have interacted with our registry contract. Okay, let's go to the next thing. A tenant resource, and this is by far the most important. So every registry contract must define a tenant resource that every tenant will receive. In it is all the data the contract would normally store at the topmost level, so any contract level variables and stuff, plus anything you would normally put in account storage inside the contract's init function. And we will go over a specific example of what these two mean in a second. So example, if a contract has one contract variable called total supply and stores an NFT minter resource in account storage in the contract's init function, the tenant resource would have two things, both that total supply and also that NFT minter resource. And this, what I'm describing here, is the exact scenario we have in the repo that I will be going over in a second here. So if you don't understand this, we will go over this in a second. 3, an instance function. All this does, there's a lot going on here, but all this does is return a new tenant resource to the caller and increments client tenants like I described before. And then lastly, a get tenants function, and all this does is return client tenants back. So those you can see here, we have client tenants, the tenant resource, instance, and get tenants. Now you'll notice that the instance function takes in a reference to an auth NFT. So if you haven't registered with the registry service yet, and you haven't actually gotten an auth NFT, you won't be able to interact with any of the registry contracts simply because it requires a reference to an auth NFT. All right. So now we'll actually go to a sample registry contract. This is a registry NFT contract, and we're going to be going over how this contract actually implements the registry interface that we just went over. So you'll notice that, like I said in week 2, day 1 content, the contract interface defines stuff that is required to be implemented. So in the registry interface, there's 1, 2, 3, 4, 5, 6 things here. And all 6 of these things must be implemented by the registry contract. So you'll see there's a client tenants here, just like we saw before. There's we'll come back to this in a second. There's a tenant resource, like we just saw. And it's named tenant, so this satisfies the interface as well. There's an instance function that we saw in the interface, and this takes in the auth NFT reference that we described and returns a new tenant to the public. And then get tenants, which just returns client tenants back to the caller. So you can see that our registry contract has properly implemented our registry interface. All right, now let's go over what exactly this registry NFT contract means. So a registry contract we also refer to as a composable contract. And let's get into what exactly this is. And this is more of the beefy part of the lesson. So a registry contract is a composable. Oh, and also, if I'm going too quick, then please ask questions or tell me to slow down. I will of course do that, and I'll also increase the font size in case anyone's having a hard time reading this. And also, if I'm scrolling too fast or talking too fast, please just let me know to slow down, and I will, of course. So a registry contract is a composable contract, right? So we refer to these two as the same thing. It can be made by anyone as long as it implements the registry interface. And that's what we just saw, right? The registry, NFT contract implements this registry interface. And we saw how it does that by including all of the 6 things. So the point of a registry contract is to make it so that all data is no longer stored in the contract. Rather, it is stored in the tenant resource that you define in this contract, right? So all the data is no longer stored. Well, I mean, I guess not all of the data, because you have data like here at the top level, but I mean like data that you would normally store. So for example, in this NFT contract, you would normally store a total supply at the top level, and also an NFT minter and account storage, and that's the data that will actually go into this tenant resource. So let's go back here, and we say, so all the data is now stored in the tenant resource that you define. And the tenant resource is composed of, and we went over this a little bit up here, but we're going to go over it again, any data that would normally be stored in the contract. So example, total supply, and anything that would be stored to account storage in the contract's init function. So what I did in this GitHub, in this repo, is I actually, if you go to the project folder, you'll see I included an NFT contract here. And we don't actually use this at all in our dApp here, but I included it as an example of a non-composable contract. And then this registry NFT contract is this exact same thing, just turned composable. So let's walk through this contract and then see how we turned this into a composable contract. So we have this total supply defined at the topmost level of the contract. This is a piece of data. You'll see there's a bunch of definitions here, right? Like events, resources definitions, resource interface definitions, another resource definition called collection. This all remains the exact same, right? We're not messing with the definitions. We're just messing with the data. So If we go to the init function, you'll see the init function also saves an NFT minter to account storage. So if we go back to our, README here, we say that there's two things a tenant should be composed of. Any data that would normally be stored in the contract. So that is exactly, I'll try and scroll a bit slowly here, but that is exactly this. So the total supply, this is normal data in the contract. And two, anything that would be stored to account storage in the contract's init function. So if we scroll down to the bottom, you'll see that this is exactly what we do right here. So those two things, if we could now go to this contract but turn composable, look at what we put in our tenant resource, a total supply and an NFT minter. So you'll see that, this is exactly what's happening here. We're just taking the contract data and the stuff that's stored to account storage in the init function and putting it here. And we've also included some extra stuff like this function, and we will learn about this in week 3, day 2. So we'll come back to this. All right. So I put this in bold, and this is very important. So a tenant resource should never be linked to the public. If it is, anyone can access a reference to your tenant and modify the data in it. So let's go to an example of how we would get a tenant like this, right? If we go to the registry folder in interactions in the transaction folder and go to NFT tenant, you'll see there's a few things happening here. We're first checking to see if a registry NFT, if a tenant from the registry NFT contract exists in account storage. So does this account already have a tenant? If not, so if it doesn't have it, then let's borrow a reference to our auth NFT. Remember, we have to have a reference to our auth NFT because if we go to our registry NFT contract, in this instance function, which is actually how we get an empty tenant, we must pass in a reference to our auth NFT, right? This is our key to get into these contracts. So we get a reference to our auth NFT and we call registry NFT contract.instance. We pass in our auth NFT and we save this to account storage. Now, many of you, might, many of you have been learning about account storage and linking stuff to the public. So if we just simply did account.link, right? And let's say we got rid of this interface and we just said account.link registry NFT contract.tenant. So if we linked this to the public, then think about the consequences of that. Anyone could get a reference to that tenant and just change total supply, right? Because they can. Or they could call this function, right? Or they could get a reference to the NFT minter and start minting NFTs. So that wouldn't be good. And that's why in this NFT tenant, we're actually, adding on a restrictive interface here, which means that we're only linking the tenant to the public with this restriction on it. And let's actually look what iTenant is. iTenant just has the total supply. So because we've, linked our tenant to the public with this iTenant restriction, we're only allowing people to read this data, right? It doesn't have public set. It just has pub on it. So all we can do is just read total supply. And we don't really care, right? If people want to, read our total supply, let it be. And this is also just a simple example of how you would, expose that kind of stuff. All right. So let's go back to our README. And are there any questions about this so far? How will you, oh, sorry, I just saw this, Busy. So how will you update auth NFTs fields after deployment? So what I meant by that is we're actually not thinking of deploying this just yet. When I was saying that we were going to add some fields to auth NFT, I was just saying that we're still thinking about this and, there's still a lot of thought to go into this. So we will do that.
Yeah, we're thinking about the architecture of it and how, in particular, we have to think about naming conventions, etc. If we have thousands of developers building these modules and deploying them, we want to make sure we think through, for example, the storage path naming conventions, what other metadata we'll pass in there, etc. So we are working our way through that.
Yep. And to also answer the general question here about updating after deployment, on Flow, this is very experimental because it's still very early stage. But I believe that on Flow, you can add functions to your contracts and you can add fields, but I don't think you can take away fields or change them. Don't take me word for word on that. I know for a fact that you can add functions to contracts. And I know that for a fact that you can also like add like resources and structs, but I don't know if you can change individual fields. I'm not sure about that. Actually, I know we had a little talk about that, BZ. So on MotoGP, you have version control. Why is that? It's actually a fantastic question. When we were developing the MotoGP contracts, you'll see if you go to the deployed contract set, there's like 5 different contracts, and the point of that was so that if they wanted to make an update to the pack, they wouldn't have to also mess with the NFTs in the same contract or whatever it may be. It just makes smart contract. What's the official term? Updatability or
Immutable.
yeah. It allows you to change the contracts a little bit if you want. So that's why it has version
It's the
control.
opposite of immutability then.
Oh.
Immutable means not being able to change. So the basic model in Flow is your contracts are perpetually updatable, but then they are not really contracts are decentralized. So the idea is when you are comfortable with it, you essentially delete all the public keys on that account, and so no one can update it. So that's essentially the model they have. So that's quote unquote how you have beta contracts on Flow, is just don't delete your public keys. But as long as your public keys are there in that account, you don't have the primary feature of decentralization, which is trustlessness. You can't trust that you won't go manipulate that contract. So at some point you have to remove it if you're doing a large scale deployment or large scale minting or something like that.
Yep. All right. So let's continue with our discussion of registry contracts. So I said that there are a lot of weird things that happen when we do this, right? When we put our data in the tenant and put our account storage stuff in the tenant that would normally be, saved in the init function of the contract. So let's think about some issues here and maybe how we'll solve them. And this will lead us into today's content. So in a normal NFT contract, we would define total supply at the topmost level, like I put here. And we would update it in an NFT, resource simply by doing NFT contract.total supply equals blah, 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 +1, right? So this is what I was showing you the normal NFT contract, but this isn't the case anymore, right? In registry contracts, our total supply, there's a little star typo, but our total supply is defined inside our tenant resource because it's data, right? Total supply belongs to the tenant. So this means that anyone who has an NFT minter resource, as shown here, and we'll go over this, who wants to mint an NFT has to pass in a reference to the tenant itself and update total supply on that reference. So this is very confusing, but we will walk through this in a second. The only way we can do this, though, is if we make total supply have an access modifier of public set. Okay, so what the heck does this even mean? Well, let's go through. So this tenant, now instead of total supply being defined at the contract level, is defined inside of the resource, right? Inside the tenant resource. So if we had simply just defined this as public, right? Let's say we made this public, then inside our NFT resource, we wouldn't even be able to update total supply here, right? Because public means it has a write scope of current and inner, so we can only update it inside this resource itself. But if we want to update our total supply when we're minting an NFT, well, then we have to make this public set, right? And this is a little weird because I was describing during last Monday, week 2, day 1, that, public set should be avoided most of the time, right? It's not bad in all cases. And in fact, sometimes it's great. But you have to be careful about how you're exposing it to the public. And, it still is, as a Cadence developer, it's just weird when you see public set because it shouldn't be used. It should be used very carefully. And we'll actually go over in today's content how we put this back to being public so it satisfies our anger with public set. But again, in this example, what's happening is when we mint an NFT, we have to pass in a reference to our tenant, right? So that when we create an NFT, we can only update the total supply by updating this tenant reference. We can't just call NFT contract.total supply anymore because the total supply lives in the tenant. So we need to make sure that we're updating it on the reference to tenant, right? So it's important to realize that if we define total supply as public let total supply, this wouldn't work because public only is write scope of current and inner. And we went over this, and you might be thinking, well, this stinks. Now, in order to mint an NFT, anyone who has an NFT minted resource has to also have access to that tenant reference, which is not possible since tenant will never be linked to the public, right? We want this NFT minted resource to be owned by, maybe more people than just the tenant itself, right? Because the tenant in this case will only be one address. But, maybe we want to give NFT minted resource to 3 people that we trust. But, in this scenario, that wouldn't work because that tenant still always has to pass in a reference to its tenant resource. And this isn't good. And we'll go over in day 2 content for week 3 how we change this. But I just wanted to leave you with that, like a sense of what's the term? Leaving you on a hook or something for day 2. All right. Any questions about this? No. Okay. Cool. So the next part, which is very short, is the composed contract / consumer contract. And, this is our marketplace contract here. So, this is a contract that a developer who, would just want to create. So let's say I just really had a desire to make a marketplace and I, made this marketplace contract on my own, which is why it's in the project folder. And you know what? I'm lazy and I don't want to have to define an entire NFT by myself. Well, this, composed marketplace contract or calling contract or whatever it may be called is using the registry contract, right? So that's what it really is. A composed contract is using a composable contract. And it's, that's imported up here. And that's really all it is, right? There's some writing here, but that really is all it means. It's just something that a consumer would make, and that contract that they make would be using, the composable contracts. So the only quest that I had for you today was just more Git, and I just wanted you to clone this repo onto your computer. So if you have this, going and you've yarn started, like I've done here, and run some cool transactions with these awesome gold stars, then you're good. So as long as you yarn started, you don't even have to mess with the action cards. As long as it's just running, that's totally fine for week 3 quest 1. And the second thing I asked you to do was, you don't have to say anything, but please ask questions. And a bunch of people were asking fantastic questions. So thank you to those people. And I really just wanted you to use this quest to kind of go through these contracts and try and understand them the best that you can. So there's no real solution to go over here. It's more of just doing what we just did, where I want you to, go through these contracts and try and understand them the best that you can. So we'll definitely take a pauser there. And, if there's not any questions, we'll just dive right into the day 2 content, which is much shorter. So don't worry. I don't want to completely overwhelm you, but this is really just going over how we fix that public set problem that we were looking at. So I will pause there for a second.
Jacob, this might also be a good moment to see if anyone has kind of any questions about tenancy in general and the architecture we are proposing, because at the end of the day, what's going to happen later this week is we are going to encourage and try and figure out if there's ways in which you want to contribute and create your own composable kind of module as sort of the early pioneers, if you will, of the network. So it's kind of important to understand the vision behind what we are trying to do here. And the vision is quite simply that we want to create the world's largest repository of composable smart contracts. So we want to create essentially the NPM of smart contracts.
Yeah.
Yeah, I guess you can start then. Oh, wait, I see a question coming up. This is such a wonderful question. What would stop or discourage people from just copying the smart contract code and deploying it? Sorry, your window popped up there, so I can't read anymore.
Oh, sorry.
Smart contract code and deploy it themselves in order to avoid paying the tenant fee. So we've thought about this very long and very hard. So in addition to the developers who are writing the code, our goal is to assemble essentially an army of what we are calling validators, but really they are code auditors who work hand in hand with developers during the development phase and then post-development also, who will audit the code. And what will happen is, unlike like in today's world, an auditor is hired, they are paid one consulting fee, usually extremely high, $200,000, $500,000 or whatever. They audit and then they're done. In the model that we are creating, the auditors will work with the developers, audit the code, and if they are confident in the code, they will essentially give their seal of approval by staking funds on that code. Those funds will act as an insurance layer for people calling that smart contract, so that if there's any problem with it, those staked funds by the auditors get slashed and they can get their money back. If you just copy the code and deploy it somewhere, you won't have that layer of insurance. You won't have that security guarantee or protection. So so that's one barrier. The second barrier is that we fully expect that composable modules themselves might in turn be leveraging other composable modules, and all of them down the chain or up the stack, however you want to look at it, are going to require that auth NFT. And so if you are going to copy a smart contract module, you can, if you want to, you are going to have to dig through and copy everything down there. So imagine on an NPM module right now, if you say that I'm going to not use NPM and pull in everything, well, it's a rabbit hole, like an onion, whatever you want to call it, where if you get this one, then you got to get these three other ones, and then those three might depend on two more, and so on. So at the end of it, you've copied a lot of code, and that's when the potential for mistakes kind of happen. So we have no doubt that some percentage of people will be happy with just copying it, but we are looking to a future at a very large scale where lots of businesses and people who care about the security and safety and trust of their smart contracts are going to be using it. For them, it is going to be way more convenient to just have the insurance and pay as you go. This is why Amazon, Microsoft Azure, Google Cloud are popular. There are certainly companies today who are like, nope, we will not use the cloud. We will have our resources in-house. But then there are companies who are like, why should I bother managing all this or dealing with this when all I need to do is pay as I go? So that's our thesis. It's not unproven. I mean, it's not proven by any means. We are out to prove it because we feel that fundamentally composability is how decentralization is going to become mainstream in our world. So that's where we are headed. That's our vision.
Yeah, thank you for that great question, BZ. Skyon says, hi, I want to ask a question about this picture. Once I finished UI harness and daplib, so the daplib the daplib transaction.js and daplib script.js is auto-generated, but the content in transaction.js and script.js is dependent on the file name. Which JS is doing this job?
All right, so this is the transpiler that is in rhythm.js. It is essentially set up. There's a hot watcher there that is watching the files in the interaction subfolder. And whenever it senses a change, it regenerates the code. I don't know if I'm answering that question correctly, but yeah, the dap transaction and dap script JS are generated whenever interactions folder changes. The code that does that is in rhythm.js.
Awesome.
Awesome.
All right, let's actually just dive right into the today's content. And in this README, I actually included a review of the problem that we were going over. And, just to quickly do that, we were discussing, well, anyone who has an NFT minted resource will somehow need access to, a reference to the tenant itself, which isn't possible unless, you are the tenant who owns this resource. So how can we get around this so that anyone who has the NFT minted resource can just, call into the tenant somehow and not have access to everything, but have access to enough that you can perform this update to total supply here that you need. So this is where we're going to dive into using access control to update data. And also, I want to say that while I'm describing this, we're going to be walking through week 3, quest 2, called Composability Loves Access Control. And, in this quest, I asked you to figure out a way to restrict the tenant reference a little more so that inside of, this is, the answer, but inside of this function, we don't need a reference to the entire tenant. So this is the quest I was asking you to try and tackle, and we'll be doing that shortly. So using access control to update data. So I said this wraps up a review. You might be thinking now, this thinks in order to mint an NFT, anyone who has a NFT minted resource has to also have access to the tenant reference, which is not possible unless you're the tenant itself, because it's not linked to the public. So is it true then that only the owner of the tenant resource can mint an NFT? And the answer is, well, no. Let's see how we can solve this so that anyone who wants to mint an NFT can without requiring a tenant reference. And we'll be doing this using our lovely access control. So I'm going to come back to this and let's look at my description. So in this example, we've done something awesome. Anyone who has an NFT minter resource only needs a tenant and restricted to iTenant minter reference, which will be publicly available after the tenant links it to the public. So what do I mean by this? Well, let's look at what I wrote here, right? This is just some demo stuff I put because this contract has to implement the registry interface. So we'll skip this. But let's go right down to the tenant itself. So you'll notice that we've added a resource interface. So tenant now implements iTenant minter. So where is this coming from? Well, iTenant minter is a resource interface that says the tenant has to implement a function called update total supply that is accessible by this contract only. So you'll see that our tenant, resource obviously has to, implement this since the resource interface is requiring it, and it implements it here. So it says function update total supply, and all of it does is just update the total supply by 1, and this has access contract. So you'll notice that inside our init function, we're no longer doing tenant_ref.total supply equals tenant_ref.total supply plus 1. We're now just calling update total supply. So we're just calling this function that has access contract. So this means that, this can be called anywhere in the contract, and that's why this is allowed. And now when we pass in a reference to our tenant, we're passing in a reference to the tenant with a restriction of iTenant minter. So now what we can do is we can actually, when we link tenant to the public, we can link it with an interface that has iTenant minter on it. And that will restrict it so that, a hacker wouldn't be able to modify, other stuff we may have in here. It only allows it to just update the total supply. So let's, and again, in the transaction, they couldn't just call update total supply because this is only callable by the contract itself, right? So it's not like they could manipulate it in any way. So let's actually walk through that in our code together. So you'll notice I'll actually get rid of this for now so we can implement it together. But look at our code right now. We have a total supply, and inside where we mint our NFT, you'll see that we're passing in a full tenant reference, which we don't like. We're going to change this. And if we didn't have this function here, this would be .total supply equals tenant.total. I can't type plus 1, right? So this is what it would be originally. And this is annoying, right? Because in this example, our total supply, this would also be public set. And this is the problem that we were encountering, right? So, if we let's go to the transaction that would actually mint an NFT right here, you'll see that in order to mint the NFT, we had to borrow a reference to the full tenant. And this isn't good, right? Because only the tenant would be able to do this. So let's go back into our registry contract and see how we can make this so that, this no longer has to be public set. It can just be public. Well, let's define a function called access contract, or actually I'll make it public for now, and then we can discuss why we'll make it access contract. So public function update total supply. This won't return anything. It'll simply just say self.total supply equals self.total supply plus 1, right? Now, let's also define a resource interface called public resource interface tenant minter that exposes this, right? So public function update total supply, right? This means that our tenant has to implement it, which it already does. And, let's also have this implement tenant minter, okay? So now our tenant is also implementing this resource interface. And what this means, why this is so helpful, is because now when we get our tenant, right? I showed you this transaction earlier where we get the auth NFT, we get our new tenant. When we're exposing the tenant to the public, we can add a restriction. So registry NFT contract.iTenant minter. So because we're adding this restriction on it, this allows us inside our mint NFT function to not have to get a reference to the whole tenant, but we can get it a reference to the tenant with this restriction on it. And this is super helpful because now, we don't need to get a reference to the entire tenant. As a public user or as someone with the NFT minter, right? Because you still have to have that NFT minter resource. We can now borrow it, with, I'll add this here, with this restriction on it. And this restriction also acts as, is very helpful to us because now, that this is on it, we're allowed to call update total supply. So when we pass this into mint NFT, we're actually passing in a reference to a registry NFT contract.tenant that is restricted to this iTenant minter. So this is calling mint NFT. And if we go back to our registry contract inside mint NFT, let's find it together. Right here, we now are passing in that's restricted to iTenant minter, right? And then this is getting passed to the NFT itself in the init function. So let's scroll back up to there. And here we are. So, this is also just restricted to iTenant minter. And now what we can do is we can delete this and say update total supply. And so it will handle it for us. Now, I said we will come back to why we made update total supply public. And there's actually a problem here. And I'm curious if any of you, I'm going to pause for a second. And I'm going to ask for all of you in office hours what the problem with making this public is. And this is just a question of access control. So if we make this public, then what's going to happen if, a public user is able to borrow, a reference to, the registry contract tenant with the tenant minter on it? We'll see if anyone can answer this question. And if not, then I will answer this. Well, then anyone can increment? Yep, exactly. So if we make this public, well, then anyone with a reference to the iTenant minter can just, call this outside the contract. So we have to make this access contract. So once we do this, then there is no, there's no problems with linking this to the public because they'll never be able to call this on their own. This is only callable in the contract itself. So now we have, we've correctly implemented the iTenant minter. And now, this is now public, so it satisfies our concern. And we've added this cool helper function that is only callable in the contract that will handle the update to the tenant's data, which is total supply on its own. So are there any questions about this? And this sort of wraps up the content from today. The last section I had was just a section on nested resources and how to handle them. And this was just going over, some problems you may encounter with nested resources. And, to sum this section up quickly, I was just discussing that, it's weird to see a resource in a resource, right? This is called nested resources, where, we've defined a resource tenant and we're storing a resource inside of it. this can get a little strange. And if the more you develop on Cadence, the more you'll realize that moving a nested resource around, in this case, the minter, is super annoying and painful. And so the section was really talking about how we can add this function called minterref that just returns a reference to that NFT minter. And if we do this, well, then we can just use this reference instead of having to move this resource around all over the place. And that was really what that section was talking about. So I'll pause there to see if anyone has any comments or questions about how we handled that public set issue. And also, just to clarify, like, that public set isn't like, this isn't like death to all. It's not that bad. It's just that, in this scenario, only the tenant would be able to, mint an NFT, or they would have to link it to the public, and then that would obviously be a big problem. So Sulfur is asking, this tenant design pattern, is it only on Flow, or is it a general blockchain thing? I mean, Nick, you might be able to give a better answer than me.
Yeah. So multi-tenancy is something we use every day. If you go to any SaaS website today, just pick any website where that website appears to be different for each individual user, although it's only one application. That's a multi-tenant application. And it's even more pronounced if you can have your own sort of domain or URL and you're using that one application. So that's a standard kind of design pattern, one application pretending to be serving, not pretending to be, but serving multiple tenants. So the way it's implemented in Flow right now is our first stab at it. Obviously, the architecture of Flow with its resources and its ability to actually physically move resources is very well suited for this. But we will also be implementing this in other blockchains, in particular EVM chains. So I already don't have much here, but I presume whatever little bit I have will be gone once I've finished implementing this in Solidity and Rust and what other languages we support. But our goal is to make it blockchain agnostic. So the design pattern is the same on the registry, but you can pick the chain you want, and eventually there'll be bridges to chains also, so that won't matter. But so short answer is the tenant design pattern is a common pattern in Web 2.0, and we have specifically modified that so that it works in a modern blockchain context.
Nice.
All right, Jacob. So are we going to wrap this up?
Yeah, that's all I had for today's office hours.
All right, great. So I guess Jacob and I will be working on tomorrow's content for you and getting that ready. We really appreciate everyone who took the time to attend the office hours and ask questions. I'm sure many of you will be watching this later. We'll look for your questions in Discord. I'd be happy to answer. I see a question coming up from Jal, so we'll wait a little bit on that. But we are super excited about this architecture because it fundamentally opens up a new model of open source, which is monetizable open source. That is the hardest challenge right now in computing. It's how do you monetize open source? And most open source companies end up doing it by way of having support indemnification and other non-code related mechanisms to do that. I know because I built an open source company and sold it, and it was really, really hard. And with this architecture that we are building now, we are opening up the ability for developers everywhere to create a small blockchain primitive, one that solves one problem really, really well, and deploy it and then forget about it. And just like in music, people release a record or a track and then get paid royalties forever, it's going to be exactly like that. You release this smart contract module and it gets deployed, and then as long as people are using it, you get paid. So that's kind of the model we are putting here. Thank you. Appreciate that compliment, Jal. She says, just want to say thank you. And this infrastructure design is really amazing. So appreciate that very much.
Thank you so much, Jal.
Worked really hard on it, and we're exceptionally proud of it. So thank you.
Yep. And thank you for all your hard work on your quest too. Doing a great job.
Yeah, and this was asked earlier, but I'll just kind of summarize the response. Is what would stop people from redeploying that one primitive? And so our answer to that is there's going to be an insurance layer. So if you just copy the code and redeploy it, you are the only person who's going to use it, because other people can't trust what you've done with the code. If you've changed even one tiny little thing in there, who knows what that is. And like just today we saw the massive hack, $600 million, etc. It's pretty easy to have that kind of stuff. So people are going to trust smart contracts that are audited, and we are going to have this insurance layer provided by the auditors. So also the other thing is you cannot redeploy without redeploying every other primitive that one depends on, because every one of them is going to need an auth NFT. So again, that's basically the solution. And by the time this goes live, we will probably have other protections also. But our primary thesis is that businesses in particular will trust insurance layers. So the question is the insurance layer something on chain? Yeah, absolutely. So any auditor who has audited the blockchain primitives, that have been uploaded to the network, the registry, they will stake funds on it, and their income is going to be determined by how much they stake. So if they want more income from the use of that primitive, they're going to stake more. And if there's a problem with that primitive, then their funds get slashed, and so they will lose money. So as long as you see that an auditor has staked money on there, you know that you can trust that code. So that's essentially the insurance layer we are referring to. So I will toward the end of the week create a much more detailed video on this, because we didn't want to inundate you with a lot of detail up front on it. So I kept it super high level in the first video, but expect to see another video for me where we go into a little more detail about it. And again, our hope is that emerging from this bootcamp, there will be some number of you, a cohort, if you will, that we will create essentially a special channel, and we will work very closely with you to bring your vision of some blockchain primitive to market. And we will also have rewards, etc., for that. So our goal is identify developers here that can work and sort of be the pioneers of this network, and we'll work with them. Flow, we will compensate them, etc. So that's kind of where we are headed. So the last question here is around an error. What I'm going to do is, well, it might help anyone, so I guess I'll keep the stream running. So go ahead.
I believe this is unrelated to the.
Okay. Yeah. So thanks. Yeah, that was. We are really, really excited about it, and we are looking forward to having all of you guys participate with us. We will work very closely with you to think of an idea, or you think of the idea, We will help you architect it, you develop it, we will help you mold it, get it to market, and then ship it. So that's what we are excited about. So thanks everyone for attending today's office hours. We'll be continuing to answer questions online, but I'm going to turn off the stream now. Have a great morning, evening, afternoon, night, wherever you are. Bye-bye.
Bye, everybody.